All right, welcome to the final part of these notes with complex bases. Let's go to the next. Three x plus 2 all squared, subtract 81. So we're going to make our two sets of brackets, put the square root of the first term in the front of each bracket, and the square root of the last term in the back of each bracket. So 3x plus 2 goes in the front, 9 goes in the back. Make them conjugates, one negative, one positive. We're done factoring. Now I want to simplify inside the square brackets, eliminate the round brackets. So 3x plus 2 minus 9 gives us 3x minus 7. 3x plus 2 plus 9 is 3x plus 11. We're done factoring that complex difference of squares. One more. 25 times x plus 4 all squared, subtract 49. All right, the square root of this first term is 5 times x plus 4. The square root of 49 is 7. So 5 times x plus 4 goes in the front of each bracket, 7 goes in the back. Make them conjugates, one negative, one positive. We're actually done factoring. Now we're going to simplify. So we have to expand out inside the brackets 5 times x, 5 times 4 in both sets of square brackets. So we get 5x add 20 minus 7 times 5x add 20 plus 7. Simplify that. We're good. Done factoring. Now we've got a complex base in the second part as well. So the square root of x minus y all squared is x minus y. The square root of x plus y all squared is x plus y. So we make our two sets of brackets and we put those square roots in the front and back of each bracket. Square root of x minus y all squared is x minus y. Square root of x plus y all squared is x plus y. Make one negative, make one positive. We're done factoring. Now simplify inside each set of square brackets. Get rid of these brackets, x minus y. This negative sign goes to both terms, minus x minus y. Over here it's x minus y plus x plus y. So the key here is to make sure this negative sign goes to both terms inside the blue brackets. Now we simplify x minus x, that's 0. Negative y minus y is a minus 2y. Here x plus x is 2y. Negative y to add y is 0. So we could multiply these two monomials and get negative 4xy. All right, the next one here, same idea. Take the square root of each term, make them conjugate binomials. So 2x minus 1 is the front of each bracket, 3x plus 2 goes in the back of each bracket, and make them conjugate binomials. One negative, one positive. We're done factoring. Get rid of the round brackets inside. Make sure you multiply both terms of this blue bracket by the negative 1. So it looks like this. We now combine like terms. 2x take away 3x, minus 1 minus 2. So you get negative x minus 3 in the first bracket. You get 5x plus 1 in the second bracket. Next one, same idea. Square root of 2x minus 1 all squared is 2x minus 1. Square root of 7x plus 4 all squared is 7x plus 4. Make them into conjugate binomials. Keep track of your brackets. One's negative, one's positive. We're all set to go. Done factoring. Combine like terms. Get rid of the negative sign. Multiply through the brackets by negative 1 here. Multiply through by positive 1 on this side. So 2x minus 1 minus 7x minus 4. 2x minus 1 plus 7x plus 4 in the second bracket. Combine like terms. 2x minus 7x is a negative 5x. Negative 1 minus 4 is a negative 5. Here we get 9x plus 3. Every question up until this one, at this point we were done factoring. But if we look closely at these two binomials, there is now a common factor in the first bracket and there's a common factor in the second bracket. So here I can take out a common factor of negative 5. In the second bracket we can take out a common factor of positive 3. So I divide this one by negative 5, I get x plus 1. Divide 9x plus 3 by 3, I get 3x plus 1. we go negative 5 times positive 3 is a negative 15 times x plus 1 times 3x plus 1. That one's completely factored. Let's try another one. Square root of the first term is 5 times x minus 2. Square root of the second term is 7 times x plus 1. Make them conjugate binomials. Square root of the first term, square root of the first term, square root of the second term, square root of the second term, one negative, one positive. We're done factoring. Expand out the brackets, combine like terms. 5x minus 10, negative 7x minus 7, that's our first bracket. 5x minus 10, add 7x plus 7 in the second bracket. Now combine like terms. 5x minus 7x, so negative 2x, negative 10 minus 7 is a minus 17. Here we get 12x minus 3. Last step, look for any common factors in these final brackets. Negative 2x minus 17. You could take a negative 1 out, your choice. Here, we definitely want to factor out a 3. Alright, so take out a 3 from the second bracket. We're left with 4x minus 1. Let's look at some perfect square trinomials. These ones are a little nicer than difference of squares with complex bases. Looks like a complex trinomial because the term in front of the a squared is, the coefficient in front of a squared is not 1, it's 9. So we could use decomposition. Or we could notice that the first term has a perfect square root. The last term has a perfect square root. So 3a and 20. And if you multiply those together, the square roots, that is, 3a times 20 is 60a. If we double it, we get 120a. Hey, that sounds like squaring a binomial. So this could be factored as 3a plus 20 all squared. That makes this a perfect square trinomial. So the square root of the first term, 3a, the square root of the last term is 20. If I multiply these two terms together and double it, I should get the middle term. If that holds true, then it's a perfect square trinomial, and I can factor it as a binomial squared. Let's see if this next one is a perfect square trinomial. Square root of 81a squared is 9a. Square root of 16 is 4. If I multiply 9a by 4, I get 36a. Doubled is 72a. So the middle term satisfies. I should be able to factor this as 9a and 4. Middle term of the trinomial is negative, so it should be 9a minus 4 all squared. Try the next one. Square root of 100a squared is 10a. The square root of 49 is 7. Multiply 10a by 7, and you get 70a. Doubled is 140a. The middle term is negative, so my binomial squared should be 10a minus 7 all squared. So if this satisfies as a perfect square trinomial, it is a binomial squared as a factor. Try this one. Square root of 28a squared is not a perfect square. 7 does not have a perfect square root either. So we're going to have to take a common factor. That's the first kind of factor we should always look at. So I factored a common factor of 7. I divide a return by 7. We get 4a squared plus 4a plus 1. I look at this trinomial, and I notice that the square root of 4a squared is 2a, the square root of 1 is 1, 2a times 1 is 2a, doubled is 4a, so it factors as a perfect square trinomial. So common factor first, then factor as a perfect square trinomial, we get a binomial squared. Yeehaw, well done. Alright, let's just have a quick summary of all the factoring methods that we should now have in our arsenal to factor any expression. Step 1, we should always look for a greatest common factor. Alright, it's used in every question. We always check for that first. Next, you want to check if we can factor by grouping. This is a form of common factoring. It's usually used to factor a 4-term expression. You pair up the terms, and you look for a greatest common factor. We see this used lots in the method of decomposition with complex trinomials. Look for a difference of squares. Recall that a difference of squares is a 2-term expression where both terms are perfect squares, and the operation is subtraction. The sum product method we use to factor simple trinomials. Method of decomposition we use to factor complex trinomials. We decompose or break down the middle term, and then we factor by grouping. A perfect square trinomial, we just looked at that, has its first and last terms as perfect squares, and the middle term is twice the product of the two terms of the binomial. Great. That's a summary of our factoring methods. We should now be able to factor any expression given to us. Here's the assignment. We will be working on that in class next day. See you then.